We know that in last class we have seen what is the escape velocity and what is the derivation, and that all we discussed it. And I think I have taught you the 5 points. Am I right, everybody? So that 5 points, of course, today again there is a situation we'll discuss that 5 points. So what is the basically what is the velocity of any planet? That is what escape velocity of any planet. What is the formula which is equals to root over 2gm divided by what? All of you divided by r. We got it. Now, if you have taken for Earth, so what is the velocity? Velocity for Earth, if you have taken, suppose if it is there, root over 2gr. 2gr. Am I right, guys? Please respond. So this is what the velocity. That is what where the particle is very, like we can say, on the surface of the Earth. So now we all knows that. And what is the Earth escape velocity? Everybody, for Earth, what is the escape velocity? Which I have been taught you. So which is approximately equals to how much, guys? All of you. So 11.2 kilometer per second. So this is what is the Earth escape velocity approximately. So I think up to here I have taught you. Am I right, guys? Please let me know. Derivation. Is it clear, brothers? So now, based upon this, let us solve. What is the escape velocity when you have been taken? For example, let me consider, write the question actually. So today's class will start with the question itself. So let me take, we all know, so I'm considering a planet, which is call it as Earth. So Earth mass is m, and the radius of the Earth is, we all know that r, and the certain mass m is present above from the surface of the Earth of a height h, which is also equals to radius of the Earth. Do you understand what I'm saying, everybody? Which is also equals to capital R. Clear, Mr. Rudreswar? Now, from there, it has been projected with the velocity, that is what escaping velocity, so that it will go to the infinity. So, somewhere it will be escaping velocity, we have been finding. So, what is this escape velocity, which has been projected r distance above from the surface of the Earth? That is what is the question. Option A, 11.2 kilometer per second. Option B, 5.6 kilometer per second. Option C, 7.9 kilometer per second. Option D, 6.1 kilometer per second. So everybody can try it. So it's very simple sum, but you need to complete concepts. So we all knows that conservation of mechanical energy. What is that? Everybody. So please respond, all of you. So if it is on the surface of the Earth, formula is which is equals to root over gr. But if it is normal condition, above height, if it is normal condition, what is the formula? Escape velocity formula. Everybody, 2gm divided by r. Am I right, guys? All of you? Okay. Is saying 11.2 kilometer per second. It is wrong. Okay, any other answer, Mr. Rudreswar? Pradosh? So we all knows that conservation of mechanical energy. What is that? Initial mechanical energy is equals to final mechanical energy. Am I right, everybody? Please respond, guys. So we all knows that when the body will reach us to the infinity distance, we all knows that velocity of the body is zero, final velocity, potential energy is zero. As velocity is zero, then kinetic energy is also what? Everybody, kinetic energy
Zero.
zero. So final, it is zero. Initially, what is the potential difference? If potential energy, anybody, distance between them. This is r and this is also r. Then what is the potential energy? Speak loudly. Minus gm. What is the potential energy formula? Anybody can tell? First of all, tell me that. How many of you remember? I need to know. What is the gravitational potential energy? Everybody? Minus capital G into m1 into m2 divided by r. Am I right, guys? Yes. Please learn the formulas. Formulas don't know. It is not easy. It is. Okay. So now what is that here? Capital M mass and that is small m mass. So capital M, m1, small m, m2 divided by, what is the distance between them? Everybody? This is r and this is also r. So totally how much, Ra? All of you. R plus r, which is equals to how much, guys? Yeah, Kadri is saying 7.9. Very good, Kadri. So which is equals to, yes, Rudreswar, how much? R plus r, which is equals to 2r distance plus, as it is thrown, already is having a velocity v, so that kinetic energy equals to half into v square, mv square. So now which will come this side, half mv square is equals to g capital M into small m divided by 2r. So 2 will get cancelled, will get cancelled. So what is remaining, everybody? V square, that is what escaping velocity square is equals to gm by r. So escaping velocity is equals to root over gm by r. Clear, everybody? All of you understand? Please respond, everyone. So now, if you have noticed this one, so basically at the normal condition, what is the escape velocity? Anybody can tell? Normal condition, what is the escape velocity? The escape velocity is equals to root over 2gm divided by r. Am I right, guys? Speak, guys, everybody. So now, here we got it root over gm by r. So something is missing. What is that? Anybody can tell? All of you? So which is missing? What is missing? So root 2 is missing. So the escaping velocity is equals to, I will write normal escaping velocity divided by root 2. Am I right? See that, everybody. If I multiply with root 2 divided by root 2, so if it will become, what will happen, everybody? Root over gm, that's what 2gm divided by root 2r. So this root over 2gm divided by r, which is equals to normal condition escape velocity. Am I right, Pradosh? Rudresh, sir, understand or clear? Yes. So
Yes, sir.
now means what is the new escaping velocity? Normal escaping velocity, we all knows that approximately equals how much, guys? 11.2. Clear, everybody? So 11.2 divided by root 2. So I'll multiply with the root 2 and root 2 denominator and numerator, which is equals to 11.2 root 2 into 11.2 divided by 2. So which is equals to, you can see, we all know root 2 value 1.414. 1.414 into 11.2 divided by 2. Make it quick and tell me what is the answer. Nearest it will come. For exact it won't come. So it will come approximately 11.2 divided by 2, which is equals to 5.6. 5.6 into 1.414. So approximately what is the answer? 7.9 kilometer per second. So this is the escaping velocity of an object when we have been thrown, or that what a height is equals to radius of the earth above from the ground. Then at that height, the escaping velocity, which is equals to 7.9 kilometer per second. So answer, what is the correct answer, everybody? Option C. I hope you all understand. Anybody having doubt, you can ask me. Mani and Samya, are you clear? Mr. Rohit, Murali, call to the Pradeep, somebody. Pradeep and Narayan. Any doubt, anybody can ask me. Do you understand? Everyone, Mr. Kadir, are you really did or are you done without doing a guess? Yeah, very good. Do it, everybody. Others also. Others understand, Ara?
Sir.
Rudreswar?
Yes, sir.
No. Completed means let me know. We'll proceed. Mr. Rohit, Rishi. Is Rishi there?
Yes.
Yeah. Vinci, are you getting? Are you trying or not?
Yes, sir.
Yeah. So now I will give you. There is a question. So let me take, if it is completed, let me take a capital M1. First mass is capital M1. So another mass is capital M2. So let me take, there is another mass between them. There is what third mass, whose mass is small m. So from M1 to this distance is, let me take R1, and M2 to M2, this distance is R2. Now, this body has been projected with some velocity. So it will go to the where actually infinity. That's what, why infinity taking already last class we have been done. Am I right, guys? Everybody? Yes or no? So that is what. So now, in this situation, what is the escape velocity of this? This is what you have to calculate it. Let me see how many of you will try. Everybody make it quick. So anyhow, if it will reaches to infinity, what will happen, everybody? Final potential energy and final kinetic energy, everything will become what? All of you? Yes, please. Zero. Am I right or wrong? So conservation of mechanical energy. So initial potential energy plus initial kinetic energy equals to final potential energy plus final kinetic energy. Now, what is the initial potential energy? Two bodies is there, distance between them and distance between these two also. So what is the basically potential energy formula is what? Minus G into M1 into M2 divided by R. So first these two bodies I will consider. So what is that? Minus G into M means M1 into small m divided by R1. Next, this is also minus of minus G, that's what? Minus G into M2 into small m divided by R2 plus what is the initial kinetic energy? It has been projected with the VE velocity. So plus half m VE square, which is equals to what is the final potential energy? Everybody, it reaches to infinity. Velocity is 0, final potential energy is 0, kinetic energy also what? Everybody, speak guys. 0. So 0 plus 0. Now, of course, everywhere mass m, small m is there, I will get cancel out. Any problem, anybody can tell me? So V square by 2 is equals to this, both the things will come this side. So it will become G into M1 divided by R1 plus G into M2 divided by R2. Any problem for anybody? You can ask me. Are you clear, everybody? Yes, please. So that next escape velocity is equals to this square is equals to this 2 will come this side. So 2 of G into M1 divided by R1 plus G into M2 divided by R2. So now both cases G is common. I'll take this G outside. So 2G into M1 divided by R1 plus M2 divided by R2. So I will take it as LCM. R1, R2 is the LCM. If it will take, what will happen, everybody? R2 M1 plus R1 M2 divided by R1 R2 into 2G. 2G, which is equals to square of escaping velocity. So what is the escaping velocity formula? Which equals to root over 2G into R2 M1 R2 M1 plus R1 M2 divided by R1 R2. So this is the formula for calculating a escaping velocity when a body of mass m is placed between the two masses m1 and m2. That is what you have to remember. I hope you all understand. Anybody having any doubt, you can ask me. Are you clear, everybody? Do you understand, everybody?
Yes, sir.
Yes. So do it, everyone. Any doubt? Let me know. Are you clear, everybody? Yes, Rudresha, Pradosh?
Yes, sir.
Okay.
Yes, sir.
Now, the most important sum and the most actually it is very tough for people, but not for you. If you have understand the concept, this is the deadliest sum. It's the easiest one. So which has been asked JEE Advance actually, not even in mains. So JEE Advance 2017, if you have seen that. So this is the sum is asked about it. So let me take what is the sum exactly, all of you observe. So a sun is present, that is what a sun, and there is a earth. Okay, everybody, this is what actually earth. So earth is having a mass m, and that's what, let me take mass of the earth is me and mass of the sun is ms. Okay, and the distance between them from the centers, distance between them from the centers is r. Okay, Pradosh, can you understand? All of you. And there is a small m mass. There is a small m mass which is escaping away from the sun direction. That is what? It is not moving towards the sun. It is moving away from the sun direction, from the earth surface. So the particle of mass m, small m, is escaping from the earth along the line joining. Observe very carefully. Along the line joining earth and the sun and going away from the sun, going away from the sun. So now here, what is this escape velocity they are asking? Option A, 22 kilometer per second. Option B, 42 kilometer per second. Option C, 62 kilometer per second. Option D, 72 kilometer per second. I hope you all understand the question, what they are asking. Everybody, are you clear? Mr. Rudreswa? So now the given information is mass of the sun is 3 into 10 to the power of times of mass of the earth. Almost 33 lakhs of earth is equals to mass of one sun. Just the given information. Next, radius of sun. Radius of sun, sorry, not radius of sun. The R is equals to, if you have noticed it, R means what? Distance between the sun and the earth from the centers. R is equals to 2.5 times into 10 power 4. That is what? 25 lakhs times of radius of earth. That is what you have to remember. Okay, sorry, 25,000. So this is what R is equals to 2.5 into 10 power 5, 10 power 4 times of radius of earth. This is what is actually the question. So what is the question? The particle is escaping from the earth along the line joining earth and the sun and going away from the sun. That is what is the question. So now, what is the escaping velocity at the surface of the earth? Anybody can tell? We all people knows. What is the escaping velocity when we consider only earth alone? Everybody? Just we have been done. What is the escaping velocity from the surface? Yes, Rudreswa. Fourth point. Escaping velocity is equals to how much, guys? 11.2 kilometers per second. If you are not involving no interest means, then just leave it, no problem. So at the surface of the earth, what is that, everybody? What is the escaping velocity? All of you. 11.2 kilometers per second. Clear? So now we want to find the particle is escaping from the earth along the line joining the earth and the sun and going away from the sun. Then what is that they are asking? So observe very carefully. This is the sun and this is the earth. So earth is, see that this is the particle which is escaping. That is what M. So but from here to here you can see. From here to here, what is that, everybody? We used to call it as a small r. But if you observe very carefully, from this point to this point, something we used to call. Can you tell me, Mr. Pradosh, Rudreswa? This is earth. What is that call it as? If we consider earth is a spherical in shape, from here to here, something we can call radius of the earth. Am I right, guys? Speak, guys, all of you. That is what. So now, this particle will go with some escaping velocity, how much it is, so that it will go to what point, everybody? It will go to infinity. If it will go to infinity, velocity is 0, potential, final potential energy is 0, final kinetic energy also 0. So now, just what is that? Conservation of mechanical energy. What is the formula? Conservation of mechanical energy. Final initial potential energy plus initial kinetic energy equals to, what will happen, guys? Please respond. Final potential energy plus final kinetic energy. So we can say when the body will go to infinity, what will happen? Final potential energy 0, final kinetic energy also 0. Now only initially two bodies we have. Verify it, everybody. One is what? Earth, mass of earth and the small m mass. Next one is mass of sun and the small m mass. So what is the distance between the earth and the surface, this small m mass? Anybody can tell? Earth and the small m mass. What is the distance? Everybody. You say means it is nice. What is the distance between the earth and the small m mass? Earth and small m mass. R. Radius. What is the distance between small m and the surface of the sun? Sun. How much it is? R plus R. Am I right or wrong? Everybody? Will you all agree with me, guys? Please respond. Everyone? Yes, that is what. So now if you have noticed it, so what is the potential energy here? Minus G into mass of earth into small m divided by capital R minus of initial potential energy between mass and sun minus G, that is what? Minus G into mass of sun into small m divided by R plus R. Next, also body is escaping, kinetic energy is there, half into mv square. So everywhere something is common, we can strike out. What is that? Small m is there, we can remove it. And I can say this one is v square by 2 is equals to, that is what escaping velocity. So this all will come this side. Mass of earth divided by 2, that is what? G. Gma divided by R plus Gms divided by R plus R. Now the given question, if you observe very carefully, small r is equals to something. Can you check it, everybody? What is the given question they have given? All of you? Given question how much? Please
2.5 into 10.
2.5 into 10 power 4 times of radius of the earth. Means compared to R, radius of the earth is extremely smaller. Am I right or wrong, Pradosh? Mr. Rudreshwar, do you understand this point? So what does it mean? R plus R is almost approximately very small, almost approximately equals to what? Everyone, as it radius of the earth is very smaller, R is very smaller, it is approximately equals to R. So I will write for potential, that's what? Escaping velocity square divided by 2, which is equals to G into ME, mass of earth divided by radius, plus G into M, mass of sun divided by R only, small r. Clear, everyone? Understand, Ara? Everyone, Pradosh? That is what it is. Now, what will happen, everybody? Here, you can check it, everyone. So this one, if you notice it, so V square, escaping velocity square divided by 2 is equals to, so if you observe very carefully, mass of sun is equals to something they have given. Check in the book and tell me, what is the given data? Mass of sun is equals to, what is given? 3 into 10 power 5 times of mass of earth. Next, R is equals to what is given? 2.5 into 10 power 4 of radius of earth. Yes, guys, respond. So that's what it is. So I'll replace it. So mass of the earth divided by radius of the earth plus here G into mass of sun is equals to 3 into 10 power 5 times of 3 into 10 power 5 times of mass of earth divided by radius of earth. Sorry, R means 2.5 into 10 power 4 5 times of radius of earth. Just we are replacing. So now you can notice it. This one I will write. So 10 power 4, 10 power 5 will get cancelled. What is remaining, everybody? 10 power 1 is remaining. So 3 and 2.5, I will write it as you can see. So can I write it as a 30 by 25? Any problem, Pradosh? This 3 divided by 2.5, can I write as a 30 by 25 into 10 power 1, mass of earth divided by radius of earth. Any problem, guys? Please respond, guys. That is what? Now 5 table. Sorry, yeah, 5 6 are, 5 6 are, 5 5 are. So 6 by 5. So G into ME divided by R plus, this will become what? 6 into, that is what? 60. So 60 by 5, how much, Ra? 60 by 5, how much, guys? 6 1 are 60. 60 by 5, how much, everybody? 60 by 5, G into mass of earth divided by radius of earth. 60 by 5, how much?
12.
12. So G into ME divided by R plus 12 GME divided by R. So which is equals to 12 plus 1, which is equals to how much, everybody? 13 GME divided by RE. Mr. Rudreshwar, can you able to understand? Mr. Pradeep, Rohit, 13 GME divided by RE, which is equals to, now you can say, velocity square divided by 2. 2 will come this side. So square of velocity, escaping velocity is equals to 2 into 13, which is equal, directly I am writing. So you can notice it, all of you. 2 into, I will write this one as a 2 into GME, GME divided by RE into 13. Okay. So this, if you notice it very carefully, this 2 GM divided by R, which is equals to something. Of course, let me take the square this side. Square will come this side, will become root. So root over 2 GM divided by R into root 13, I will write it. So root over 2 GM divided by R, which is equals to something. Anybody can tell? All of you? Root over 2 GM divided by R, which is equals to something. Approximately what velocity? Escaping velocity. Am I right or wrong? Please respond.
Yes, sir.
Yes. So that is what? So V is equals to at the surface. We all knows that root GM, 2 GM divided by R. Am I right, Ra? Respond, Ra, everybody. That is
Yes,
what
sir.
it is. So now, in place of root 2 GM divided by R, I will write 11.2 into root 13. So now, root 13 value, can you tell me, anybody? What is the root 13 value? Root 13 value. You should find it and you need to know it also. Root 13, how much, Ra, brothers? So anyhow, root 9 is 3, root 16 is 4. So this root 13 means it will be approximately closer to the 4. That is what, let me take exact value is 3.6 actually 0. So I will take 3.6. Okay, so 11.2 into root 13 means 3.6, which is equals to, how much is the answer, everybody? Yes, please. 11.2, if I multiply it, I'll get approximately, what is the value I'll get? I'll get it 40.38 kilometer per second. So if you observe the MC options, there is no kind of exact answer, but there is a nearest value because there is a larger difference between them. So we can say nearest value is the answer. So what is the nearest value? Verify it, everybody. Nearest to that, nearest to 40, which is their closest value, 42 kilometer per second. That is the answer. This is the JEE Advanced 2017 4-mark question. Imagine that. So concept, it is maybe the time delaying at the beginning, but definitely you all can do very well if you have been a strong concept. You are clear with the concept, definitely it is very easy. I'm expecting you all understand this question. Anybody having any doubt, any point, you can ask me, or else we'll proceed further. Are you clear, everybody? Yes, please.
Yes, sir.
Yes, sir.
Sandra, Pradosh. Any doubt, you can ask me. Like these questions, many questions they asked in many years in JEE Advanced from this escaping velocity concept. Are you all understood or not? You tell me. If not, we'll go to the next concept. Please make it to everybody. Clear, everyone? Yes, Mr. Pradosh.
Yes, sir.
Yeah. Solve it. Yura Rudreswar, Clear, Kadri.
Yes, sir.
Yeah. If it is completed, we'll proceed further. We'll go to the next concept, everyone. Is this question completed, guys?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Anything doubt, you can ask me in this. Now, so the next concept which we are going to study is another one most important concept, which we are like this is the concept related to even the circular motion what we studied a long period of time. So now that is what is the concept, call it as a motion of satellites. That's what about orbital velocity. So what is the orbital velocity of the satellites which are near to the earth, which are far away from the earth? Not only it is man-made satellites, there is a natural satellites also. So that is what is our next concept. So all of you keep ready. Motion of satellites. So and their orbital velocities. So this is also one of the most important concept for IIT JEE mains and as well as NEET. But advance also, many times they will ask the question from this. So that's why, so always do it. Mr. Sai Karthik, can you able to understand or not? Everybody? So now if you have noticed a motion of satellites, forget about it. In last class, I have told you, if you have been launched a satellite from the Earth's surface with a certain velocity, so let me take the first point. So totally 5 points we discussed it. So we all knows that according to Kepler's laws, planets are revolving around the sun in what path, everybody? Is it a circular path or elliptical orbit, everybody? So
Elliptical.
orbit. So sun is present any one of the foci and the planets are revolving around the sun in an elliptical path. Now, if you have noticed it, everybody, if you have been launched with a certain velocity, so what will happen if I consider if this is the Earth, this is the Earth. If I launch the satellite or any that's what whatever it is with a certain velocity VE. So what will happen after traveling certain distance? It will be fall into the surface of the Earth. So if I increase this velocity, that's what first. So it will follow the path. So if I launch with the velocity V, escaping velocity, something V, or let me take V1. So that will be going and taking with the orbital path. Sorry, orbital not. What is that path we used to call it as? Elliptical path. If I given certain velocity to the satellite and if I launch that one, it will go and take around the Earth or any kind of planet in a elliptical path. That is what is the path number 1. Now, path number 2, if I keep on increases this velocity, that is what? If I keep on increases that velocity is approximately equals to 8 km per second. This is particularly for Earth. Different planets, it is different. If I increases velocity approximately equals to 8 km per second, that is what even exactly if you want to say 7.9 km per second. So by that time, it will take the what path? Anybody? By that time, it will take certain path. All of you can tell me. What is the path it will take? It will take the circular path. When I given the velocity approximately equals to 8 km per second, then the satellite or whatever it is, it will take to the path 2, which is what is the path, everyone? Circular path. Clear? But the initially path, what is the path, everybody? Initial path is a what path? Elliptical path. Clear? Now again, the velocity is increases more than 8. The velocity is further increases. So at that situation, again, if the velocity goes more than 8 km per second, again the path number 3, again the orbit, that satellite, whatever it is, it will follow the elliptical path. This is our path number 3. Now this velocities keep on increases, which is approximately equals to 11.2 km per second. So by that time, what is this actually? We all people know 11.2 is something. What does that call it as? Anybody who is to call it as a? You are speaking means a teacher will get an interest. If you are keep on sitting like a dumb fellows, then what is going to happen? Already I thought. So with the velocities become 11.2 km per second. So we all knows that it will become what? What is that, everybody? It is escape velocity. So by the time what will happen if I have taken the planet, for example, this is a planet. If it has been launched, for example, I have been launched, then the satellite will goes. It will never come back to the Earth. It will goes in a parabolic path. It will just leave from the escape from the Earth surface in a parabolic path. That is why it is saying open curve or closed curve, this one. Everybody, 1, 2, 3, both are open, 3 are open curves. And the fourth one is a what? Sorry, first 3, 1, 2, 3 are the closed curves. Elliptical path, circular path, and again elliptical path. These are closed curves. And the fourth one is what? Where the escape velocity is 11.2, then it will take the parabolic path. Now, if this escape velocity is again more and more increasing, that is what? V's escape velocity is greater than 11.2. That's what? Root over 2CR, more than this. Then the satellite or whatever it is, it will escape in a what path, everybody? We already studied. What is the path actually? It will take a path of hyperbola. Hyperbolic path. So hyperbolic path it will take. Means it will never even take a parabolic. So it will just escape from the Earth. When the escape velocity, the velocity is greater than 11.2 km per second. These are the 5 points we studied. So 4 and 5, both are called it as a 4, 5, both are called it as a what? Open curves. So this is actually required when we are launching the satellite to the another planet or another kind of a substance. Like we launched Chandrayaan 3. So for them, it has to escape out from the gravitational force of Earth, so that it needs the escape velocity which is greater than 11.2. Then only it will be keep on. You can notice that path. It will be keep on revolving and revolving and revolving. At a certain situation, it has been taken to the moon. I remember, brothers, that Google and all, you can notice the paths. Am I right or wrong? So that is what. So if you want to take the satellite or whatever to the another kind of a planet or another kind of a substance in the universe, so then we need the 4 and 5 cases. That is what hyperbolic case or it is a parabolic case. But if you want to make the satellite around the planet, suppose if this is the Earth, then if you want to make the planets around the Earth, then we no need case number 1 and case number 3 also. Always case number 2 is preferred one. That is what? Make the planets to revolve in a particular path, which is the, what is the path actually? Anybody can tell? What is that path? All of you. Circular path. So this is the perfect path for the satellite. For satellite, always closed curves is needed. In that also, the circular path is preferred so that it will be keep on revolving around the Earth. That is what is the satellite, what we are sending. So always the closed path is preferred for the satellites which are revolving around the Earth or revolving around the moon or whatever it is. But if it wants to go out from the Earth gravity or the force of attraction, then